Okay, points, lines, and planes. Objective. Objective is to understand the basic terms and postulates of geometry. Introduction. Geometry is a mathematical system built on accepted facts, basic terms, and definition. Undefined terms are the basic ideas that you can use to build the definition of all other figures in geometry. Although you cannot define undefined terms, it's important to have a general description of their meaning. Undefined terms. A point. A point indicates a location and has no size. So, location, but no size. Okay, by this I mean, like, if you look at a map of Missouri or anywhere like that, towns are indicated by a point, but just by looking at that point, you can tell where they're at, but you don't know how big the town is. And this is somewhat true. I mean, I realize that if you looked at a map of Missouri and you've seen Springfield, it looks a lot larger than Webb City, but it's the idea that if you see those little towns on there, you can't understand how large they are. How to name it? To name a point, we'll use always a capital letter. So in a sentence, you'd say point A or point B, but it's always going to be indicated by a capital letter. In a diagram, you're going to see a point and either a P, or in this case, we used an A. Those are examples of a point. Okay, next we have a line. It's a straight path that extends in opposite directions without end and does not have a thickness. It has infinitely many points. So to shorten this, straight path that extends in opposite directions without end. That means without end, because you're going to run out of room. And it has infinitely many, that's a symbol for infinite, infinitely many points. And it's because it goes on and on forever. Now, a way you could indicate a line is you can say it's line AB, but because it doesn't have any end, we could also label it line BA. Now, it's important to have the arrows at the top because it indicates that it's going on and on forever. Sometimes, and let me draw the picture for you first, if I have a line and it's extending in opposite directions, so I have A and B, sometimes it'll be indicated in textbooks with italics like L, lowercase letter L, M, N, and P are the most popular. And to label that, you'd say it's line L. Okay, a plane is a flat surface that extends without end and has no thickness, and also contains infinitely many lines. So we're going to say flat surface that extends without end and has no thickness with infinitely many lines. Now, typically, you can think of a flat surface or a plane as something like the wall, the floor, something of that nature. They are indicated with 3 capital letters because that's 3 points on the plane. So we can say that it's plane ABC. Or if there is a capital letter in the corner that doesn't have a point by it to indicate that it's a point, they're labeling it as the plane, and you would say it's plane P. To indicate that, usually they look like a parallelogram when they're drawn in a textbook, and so we'd have A, B, C, or we'd have P. And a lot of times it looks like that uppercase letter is italicsed. Vocabulary, it says points that lie on the same line are called collinear points. And points and lines that lie in the same plane are called coplanar. Example 1. It says, what are two other ways to name EF? So we need to find line EF, and it's this line right here. Now there's several ways to indicate this line. We could say that it's line N because of this right here. We could say that it is line FE. We could also say that it's line EB. We could say that it's line BE, or we could say it's line BF, or line FB. There's many ways to name that line. The next question says, what are two other ways to name plane C? Now before we name plane C, I want to take a minute to point out an example of what they mean by plane C, because we have to make sure we're using the right 3 points to label the plane. Okay, I put points on the wall and on the floor so that you can see why it's important that we use the right 3 points to label a plane. Now, if you look at this, points are just a location, so even though I use post-it notes and look a little bit big, that's okay. We're just talking about location. I want you to notice that A, B, and C, points A, B, and C, they are along that edge where the floor and the wall meet. Okay? Then we have point E on the floor and point D on the wall. Now, if I said I was talking about point ADB, would you know if I'm talking about the floor or the wall? Well, of course, I'm talking about the wall. If I said plane BCE, would you know if I'm talking about the floor or the wall? Well, again, we know that I'm talking about the floor. If I ask for plane ABC, am I talking about the floor or the wall? Well, it's hard to tell because that's the intersection of where the floor and the wall meet, and there's not a distinct point on either just the floor or the wall. And so that's why it's important that we talk about having 3 non-collinear points. It's okay that I use AB or BC or even AC, but I have to include a point that's not on that line, so that way we know I'm talking about the floor or the wall. Okay, now that you can see that we need 3 points that are non-collinear, how would we label plane C? We obviously do not want to call it plane EBF because those points all lie on the same line. So we could call it plane EBG, or we could say plane BFG, because those are 3 non-collinear points. Okay. The next one says, name 3 collinear points. And so we could have, let's see, collinear means that they're all on the same line. We have E, B, and F, because notice these 3 points right here all lie on the same line. Okay. On the next one it says name 4 coplanar points. That means they all lie on the same plane, so we're looking for points that lie on this plane. And so we already know we have E, B, and F, and we're also going to include G. Now I want you to take a minute. I'm going to be looking for this on your notes. Name the plane C one other way. Okay, on your handout, and it's because of the way when you print from Google Drive on a Mac as opposed to printing from a Chromebook, it got cut off. You're missing this part in your notes. You can use undefined terms to define other terms. A geometric figure is a set of points. Space is the set of all points in 3 dimensions. Similarly, the definition for a segment and array are based on points and lines. Okay, some more terms. Now guys, here in the first chapter in geometry, the introduction to geometry, we do a lot of defining terms so that way we can use them to make definitions later. Okay, a segment is part of a line that consists of two endpoints and all the points in between them. So to shorten this, because you have a very little box, you're going to say that it's part of a line. Now when we label this, let's draw a picture first. Before our line went on, because it had arrows on each end, a segment is just part of that, so it has a definite starting point and a definite end point. So this would be segment AB. And to label this, we would say that it's segment AB, and notice we just draw a segment on top and we don't include the arrows. Or it could be segment BA. For a segment, the order does not matter. On a ray, it is part of a line that consists of one endpoint of the line on one side of the endpoint. So it's part of a line. It has a definite, the way I want you to remember this, it has a definite starting point but no end point. So part of a line has starting point but no end point. Okay, so when we look at the picture, we have a starting point. We have a direction that it's going, so I can say A, B. And when I want to label this, or how to name it, I'm going to say that it is ray A, B. Now notice I don't have an arrow over the A. That indicates that that is the starting point and it's going in the direction towards B. You can't, the order does matter on this. You can't flip-flop this one. Okay, opposite rays. It's two rays that share the same endpoint and form a line. So two rays that share an endpoint, or share the same endpoint, share the same and form a line. Okay, so now if I draw my picture for this one, I have C, and let's do A and B. And so my opposite rays would be ray CA. Notice it's starting at C here and going towards A, and CB. It's starting at C and going towards B. And notice when we put those together, it forms line AB. Example 2. It says name the segments in the figure. Okay, now there's a lot of different segments you could have here. Most people would identify segment RS, and you could call it SR, ST, and TW. Those are all segments of this line. But we also have other segments. We have segment RT from here to here, or we also have segment RW. Then we could start at S and we could have, we already have ST, but we could have SW as well. And if we start at T, we're only going to W, and we already have that one labeled right here. So those are all the possibilities. Okay, the next question says, name the rays in the figure. Okay, if I start with R, I could say ray RS. Now if I name that RS, I'm saying I'm starting at R and I'm going towards S. Someone else may have named that ray RT or ray RW. Those are all saying the same ray, so we don't want to write those again. Another way we could write this is ray, or another ray on here is a different starting point, ray ST, and we could have ray TW. But I could also point in the other direction. I could have ray WT, and when I have that, let me erase this real quick so you can see what's happening. If I start at W, that means I'm going in this direction because I'm going towards T. And I could have TR, just to throw things in a different direction. And I could have SR. Okay, the next question says, name a pair of opposite rays with the endpoint T. Okay, if I want an endpoint of T, there we go. Endpoint of T, I want to start here and I want opposite rays, so it means I want to make the line, so I could start at T and go towards W. So I have TW, ray TW, and if I want to go in the opposite direction, I'm going to start at T, and I'm going towards R and S, so you could say ray TR or ray TS. It is totally up to you. Okay, and the last one says, name another pair of opposite rays. Another pair of opposite rays is you just want to start at a different starting point. So we could start at S, and we could say SR and SW. Now, looking at this picture, is there any other endpoint that we could start with? Or beginning point, I should say. No, because if I start with R and I want to go in this direction, I don't have another point labeled there. So I can't make an opposite ray with R or W for the same reason. Example 3. It says, suppose a student picks 4 points at random from Q, R, S, T, and W shown below. Find the probability that these randomly chosen points are collinear. Okay, so I'm choosing 4 points at random. Well, if I'm choosing 4 points at random, I need to find out how many times this would happen. So if I start with R, I could have R, S, T, W. I could choose those 4 points. I could choose R, S, T, Q. Now, if I want to stick with the RST theme, I don't have another fourth choice. So RST is done. So now I want to look at STW. Well, if I choose STW, the only other option is Q, because if I choose STW and R, that's the same as this one right here. So we don't want to overlap. Okay, so how many of those, so right now I know I have all the options of choosing 4 points at random from those 5. How many of those are collinear? That means they fall on the same line. Well, that would be this one right here, so that means that our probability of this happening would be 1/3. Now guys, I got this problem from Math Excel, and so it is a type of problem that you'll see when you go to do your practice problems. Okay, a postulate or axiom is an accepted statement of fact. Postulates, like undefined terms, are basic building blocks of the logic system in geometry. You will use logical reasoning to prove general concepts. Now later on we're going to get into theorems, and theorems are different than postulates and axioms. They are something that we can prove, as these are accepted facts. Okay, postulate. Through any 2 points there is exactly 1 line. Okay, so an example of that would be if I have point A and I have point B, there's only 1 line that I can draw between these 2 points. Okay, the next one says when you have 2 or more geometric figures, their intersection is this set of points that the figures have in common. Okay, and we're going to look at some of those here in just a second. Okay, it says if 2 distinct lines intersect, so we're looking at the intersections, then they intersect in exactly 1 point. So if I have a line, we'll call this XY, and I have another line and they intersect. We'll say AB. they're going to intersect right here at point P. And they only intersect at one point. That'd be like if I gave you two uncooked spaghetti noodles and said, how many times can you get them to intersect, or where do they intersect at if you cause the spaghetti noodles to intersect? Well, there's only going to be one point that it can intersect, no matter how you move the lines. Okay, the next postulate says if two distinct planes intersect, then they intersect to form exactly one line. Now this is like when I gave you the example earlier when we were looking at the floor and the wall. The floor and the wall intersect at that line where the edge is. And if you were going to draw this, now remember, I'm not an art teacher at all. Yuck. Use your imagination. Right here would be their intersection. Again, I'm not an art teacher, but that's what it's going to somewhat look like. But again, a better visual is thinking about the floor and the wall. Okay, let's see what we can do with this information. Okay, it says, what is the intersection of plane UXW and plane STW? So first let's see what planes we're talking about. So we have U, X, and W, so we must be talking about this plane right here. And plane STW, so let's see, let me use a different color. S, T, and W. So we're looking at this plane right here. And we're looking to see where they intersect each other. And if we look at this, their intersection is right here, so their intersection is going to be segment XW. Okay, the next question says, what is the intersection of TSR and plane UVW? Okay, so let's look at that. Let's erase this. And we have plane TSR, so TSR, and plane UVW, UVW. Well, that's like the top and bottom of a box, or the floor and the ceiling. Those won't ever intersect, so the answer would be none. And it's because they're parallel to each other. They're not going to intersect. Okay, the next one says, what planes intersect at segment QR? Okay, so let's find QR. Oops, let me get that completely erased. Segment QR is right here. So we want to see where they intersect at. Well, we have the front of our box and the bottom of our box. So the front of our box, we could call that plane UVR. Or we could have said it's UVQ, or we could have said it was QRV. There's many ways to name that plane, but when we're talking about it, we're talking about the front of this prism. Okay, and it's the bottom. So we're looking at plane QRS, or you may have called it QRT or RST. Those are all talking about the same plane. It's the bottom here of our prism. The next postulate says, through any three non-collinear points, there's exactly one plane. So, non-collinear. Okay, and this is like what we talked about. Is this the floor or the wall? Okay, because remember when I had the floor or the wall, you couldn't tell which one I was talking about if I only gave you three collinear points. So we have to have three non-collinear points to be able to identify a plane. The next one says, shade the plane that contains U, X, and S. Okay, so I have U, X, and S. And I know right now some of you are looking at this and go, it doesn't have a plane. Well, planes are three non-collinear points. It doesn't necessarily have to be the face of a prism. So if I have U, X, S, that means it's this plane right here that runs diagonally through the box. So even though it's not drawn for you, the plane does exist. Okay.